Yo guys, and welcome to the channel about DIY and robotics. I came across the idea of building something cool and meaningful and something which I can show to my mom at least. Actually, in this video I'm gonna build an autonomous drone based on Pixhawk Flight Controller, of course out of procrastination. Just get a drink and enjoy. This robot shouldn't be that hard to build, but where do I start even? Basically, I want my robot to fly through the set of locations, and at the same time I also want to have a control over speed and altitude of the flight. Which sounds almost like a definition of an autonomous drone.
An autonomous drone is able to conduct a safe flight without the intervention of a pilot.
There is no question that good and reliable plan is a key to success of the project. So here is my plan. I want to start from components research, then assemble all the components, which will be the milestone of this project, configure them, and eventually fly. And what are those components on board? These schematics could answer all of your questions, because almost every drone consists of the same type of components, and I will go through it briefly so you get an idea of what's going on here. And I actually stole these schematics from official PX4 website, and you definitely want to check it out if you're building your own DIY drone. First, I want to talk a bit about my frame choice. I was considering lots of options, and I decided to stick with some big frames like S500, because I want to have more space on board for my future projects. In theory, this frame also should be durable, because the base of the frame made from carbon fiber material and the other parts made from strong plastic. Motors are doing kind of important job here. They're spinning in clockwise direction and counterclockwise direction in order to establish a force which will lift the drone up. This fancy simulation is created by NASA researchers, so you can notice the aerodynamics of this drone. It's kinda common practice to use brushless DC motors for drone builds. It turns out that for big frames such as S500, people usually use something around 900 kV motors. The motors are typically connected to ESC, and ESC stands for Electronic Speed Controller. In theory, this controller is just a MOSFET device. The controller could look like this or like this, and I will cover it later in details. Then we have battery, which powers the whole circuit. To provide sufficient voltage for the motors, the battery should not contain less than 3 cells. The battery is connected to power module, and power module powers up ESCs and motors and flight controller. Flight controller is the most important black box here. It takes input as a pilot commands and sends signals to the motors accordingly. It also takes into account lots of data from sensors such as accelerometer or GPS, so you got the idea. It's really important and crucial, I don't know. And eventually all the stuff should be connected to autopilot. Telemetry port is used to retrieve data between ground station and drone. The data sent from drone could be a position of the drone or battery level. You can also send a command from ground station to drone. Telemetry is directly connected to the autopilot. You know what? My stuff has already arrived, and let's take a look at it. Here is no-name motor. I ordered all this stuff from China, and the quality of some parts is not that good. But at this point, I just hope it will work. My brand new ESCs are already connected to the PCB. They are 40 amps, and I did not save on them because this component is affecting how smooth your flight gonna be. Luckily, this frame has integrated PCB, And this means that I can simply connect the battery's power module and ESCs straight to the frame's PCB, which is kinda cool. Yes, I assembled all these parts and I didn't film it for you guys, because I was just lazy. This is power module with 6060 port, and I can't say much about it. The battery which I purchased has 3 cells, capacity of 4000 milliamps, and a discharge rate of 30C. And the important piece of information here is that discharge rate means how fast this battery gonna discharge. And they say that it's better to have like greater discharge rate. So I followed this rule when I was buying my battery. Since an autopilot is the most important part, I decided to stick to well-tested solution, like Pixhawk. And generally, I saw lots of positive feedbacks about this product. It kinda provides high computational power, also stabilization from vibrations, which should in theory increase the accuracy of the flight. It's also cool that for my future projects I can connect this autopilot to Raspberry Pi or to any other onboard computer. You also want to have a transmitter and receiver in case something goes totally wrong, and so you can switch to manual mode. And with planned missions, something always goes wrong, for some reason. So the maximum distance on which this pair could operate is approximately half a kilometer, and this setup should provide 10 channels, which will be used for controlling the drone, sending battery data, and also switching flight modes. GPS module is crucial for autonomous flight because this module enables the drone to fly to a given GPS coordinate. And I'll place it further from onboard electronics. Probably this will increase accuracy of the GPS. Yeah, here is the telemetry port I'm planning to use. I have a feeling that I'm done with this components research. For the next video I'll bring the biggest elephant inside the room and gonna build the drone. And make sure you won't miss it, because I'm gonna show my fabulous engineering skills.